Good.
Okay, let's do the first one. What was the acceleration of the Bugatti Veyron?
0 to 60.
So Veyron acceleration is 11.2 meters per second squared. All right, let's see how long of a space it actually needs to get up to that speed, to get up to 60 miles an hour. Okay, how far does it travel as it's accelerating to 60 miles an hour? What was 60 miles an hour in meters per second? 26. 26.8
Yeah.
meters per second. Okay, that's 60 miles per hour. Yep. All right. Well, let's go to this equation here. I'm going to say that, okay, at time t equals 0, let me actually draw this box, so it's right here. At time t equals 0, the Bugatti Veyron starts out at x equals 0. At some later time, it's traveling at 26.8 meters per second. I want to get what this distance is, so that'd be x at that time. X at t equals 2.4 seconds. Okay? So, I'm going to go over to here and I'm just going to start plugging in numbers. X initial, I'm going to say is 0. The final is what I'm trying to solve for. So I do x final is the initial x position, 0, plus the initial velocity in the x direction. If it starts out at rest, that's 0. Plus 1/2 the acceleration in the x direction, that's 11.2 meters per second squared, times 2.4 seconds squared. All right, if I plug this in, what would I get for the final x position? So I get 0 is the initial x position, xi. 0 is the initial x velocity. I just need 1/2, 11.2 meters per second. That's 2.4 seconds. What's that? Well, let's see. What did everyone get?
33.6.
So what did you get?
I got 33.6.
I got 32.3.
So all you have to do is multiply 1/2 times 11.2 and then multiply by that squared, right?
2.4 squared.
Yeah, that's what I did.
So you got 33.6.
32.3 is what I got.
32. What was that?
32.3.
2.4 seconds.
Oh,
32.3. Okay.
32.
All right, that's roughly just a little over 100 feet. So this Bugatti Veyron takes 100 feet, or a third of a football field, to go from 0 to 60. So if it's trying to merge into traffic on a freeway, it doesn't really need much of an on-ramp. So that'd be pretty sweet. So,
Wonder what the insurance rates are like. Probably a bit steep.
yeah.
How do you get the 32.3 again?
So I took this 1/2, that's a 1/2, times 11.2 meters per second for this acceleration. 1/2 ax times t squared, it did this in 2.4 seconds. Okay,
It would take
so you
it
square it, that would be
32.3 meters.
roughly, I don't know, 5 or something.
5.76.
5.76. Yeah.
Okay, you want to see what it's like in a Honda? You can do on-ramp versus, Honda versus Bugatti Veyron. Now I like Hondas. I'm a big fan of them, but they're not quite as they don't have quite that acceleration unless they're souped up. You have a supercharger, a turbo, and nitrous, or something like that put together. So let's do the Honda Accord. And this is kind of more or less my one based on just kind of a figure. This seems to be about it. So the acceleration 0 to 60 is about 7.5 seconds. Okay. So 7.5 seconds, 7.5. So what would be the acceleration? Let's see if we can figure this out. So if I start this car out, it's at t equals 0. It's not moving. At t equals 7.5 seconds, it's moving with a velocity of 26.8 meters per second in the x direction. So the acceleration in the x direction would be the final velocity in the x direction minus the initial velocity in the x direction divided by time. That would be
26.8
divided meters per second divided by 7.5 seconds. And what does that become?
3.6.
So that is 3.6 meters per second squared. Okay. Now, let's see how far it traveled in that time. So I'm going to go over to here. And the final x position is equal to the initial x position plus initial velocity in the x direction times time plus 1/2 times the acceleration in the x direction times time squared. I'm going to call this equal to 0. I'm going to set that as my 0 position where it starts.
Is that always going to be 0? Or
Not
is it
always.
just because it started at 0?
I can call that the 0 position. Sometimes you can't.
Okay.
But in this problem, I can't. This, if I'm looking at acceleration from rest to 60 miles per hour, how far it traveled, the initial velocity would be what?
0.
0 because it starts at rest. And then the acceleration was 3.6 meters per second squared. This t was
7.5.
7.5 seconds. So I get my final x position is 1/2 3.6 meters per second squared times 7.5 seconds squared.
Yeah.
101.3.
100.1.
So that's 101.35 meters. So it takes roughly, a little about 3 times as far, 3 times longer on ramp to get up to that 60 miles an hour. Yeah. Kind of neat stuff. One more thing. I'll do one more. And then we'll end it. What's that? Well, the Bugatti Veyron has a W16 engine. So that's 2 V8s put together. Right, so that's 16 cylinders, and it gets about 1,000 horsepower. A little over. Yeah. By the way, like it apparently can run through all its fuel tanks in like 10 minutes or something. It's at full acceleration. Well, I don't know, I heard it said like, yeah, full acceleration will go through its tires when it's going on a track at full speed. It'll run through its tires in like 20 minutes, 15 minutes. But that's okay because it'll run out of gas. Or something like that, yeah. It's a pretty impressive car. Better be price. Dude, I don't really have time to do the next one. Any question on the homework? 2-minute question.
I know, like, I don't know.
But acceleration is the
Like, 617.